The third mechanism that we're going to explore to allow us to make use of asynchronous functions in JavaScript involves an extension to the language where there's been new keywords added called async and await. And it's going to be a little simpler, I think, to understand this than maybe the promises or the callbacks was. And this is kind of the most modern approach to doing this. So let's take a look at some of the basic ideas here. First of all, the thing that makes this really a compelling model for writing asynchronous code is that although it's still doing asynchronous things, the code appears to look quite similar to synchronous code with the addition of these new keywords in the language. It's important, secondly, to note that this still relies on promises. So async await is just kind of a convenient way to turn what are normal kind of promise returning functions into something that looks a lot more like synchronous code. And as I mentioned, there's a couple of new keywords called async and await, and we'll look at some examples here shortly. But async, this basically is a keyword that you use before a function declaration to say this is a function that's going to do asynchronous stuff. So we need to kind of let the JavaScript interpreter know that we're going to do this await behavior that we'll talk about in a second inside some function. And it's kind of easy to forget that sometimes, to add that async keyword, but the JavaScript compiler will alert you to that if you start doing await things inside the function. Okay, so async basically just decorates the function to say we're going to do asynchronous things inside of here. And then the other keyword that's added called await is what we're going to use inside the async function. So any place that we're going to invoke an asynchronous function inside of one of these functions that's got that async label on it, we're going to await the function itself. And this is the key thing. The await suspends execution until a promise settles. Remember that when we create a promise initially, it's in a pending state, and then we said that it's going to go from there to a settled state, which could either be fulfilled or rejected, depending on whether the underlying asynchronous operation succeeded or failed. So the await keyword is going to cause the execution of that asynchronous code to go forward, but it's also going to suspend the execution of that thread until the promise settles. So it's kind of like it's waiting for us, or doing the wait for us behind the scenes. Instead of us having to supply a callback to be executed after the asynchronous operation completes, or instead of us having to do an explicit .then on a promise, we can just mark the statement that we want to run with await, and that's going to cause the asynchronous operation to run, but it's also going to allow it's also going to sort of halt the execution of our function until that asynchronous operation completes. And then we'll look at an example of this. Hopefully we'll make that more clear. I just wanted to, again, highlight the notion that this requires functions that use promises. So although we'll see that the async await syntax is a lot nicer by some measures than trying to do .thens and .catches, it still relies on promises. So we're not saying that promises aren't important anymore because we have async await. In fact, we still need to know about promises in order to use async await. Particularly if we have a function that, for example, just has a callback interface, we're going to have to promisify that in order to have it behave like a promise in order to use that inside of our code that uses async await. So the awareness of callbacks, what those are, how they work, the awareness of promises, how they work, and how we can wrap a callback-based asynchronous function as a promise are both still necessary to be able to use async await. Okay, so just to refresh your memory, these are the functions that we created kind of last time. The versions of these fs.operations like fs_write file, we wrapped these in a promisification function, right, that returned a new promise, and then defined a top-level function that we can use to get a promisified version of fs_write file. And then similarly for fs_append, so we have fs_append file promise, we have an fs_read file promise, and we have an fs_unlink file promise. So this is just code from before, but again, I really want to drive that point home. We can't use async await unless we have asynchronous functions that behave according to the semantics of a promise. Okay, so let's look at an async function. So this is basically the async await version of the running example that we've been talking about throughout the discussion of async code. It's going to use those promiseification functions that we just described, except the syntax is going to be a little bit more familiar. So here's the function that we're defining. I've called it write append read unlink because that's nice and terse. And you can see here that we're still calling fs write file promise, fs append file promise, fs read file promise, and fs unlink promise, right? Again, those are exactly the same functions that we defined when we were talking about promises and that we used with the sequence of .thens with a .catch at the end. The difference here is that we're using the async and await keywords. So the fact that there's the await keyword right here, what that tells JavaScript to do is to invoke this function, which of course is going to return right away with a promise, because that's the way we've defined it. But the await will hang on to that promise and it will pause execution until that promise resolves, whether it resolves to be fulfilled or whether it resolves to be rejected. And then the next step is going to be to run the next statement at line 4 here. It's going to run fs append file promise. That's also a function that returns a promise object, right? It promisifies fs.append file. So that's going to start off this asynchronous process and return a promise right away. Again, the await keyword is going to tell JavaScript, hey, here's a promise that you're going to get. Wait for that promise to resolve, and then go on to the next step. So third thing we're going to do is await read file promise. Now notice here in the first two instances here for the write file and the append file, we didn't assign the return value to anything. And you'll remember that write file and append file really don't return anything, right? There's nothing to be returned. You give them the name of the file and the content that you want to either write to the file or append on the end of the file, and they go and do that, and they basically return nothing. So we're not consuming the return value from those functions, but the read file is different, right? You give it a file name, and it goes off, does an asynchronous read from that file, and returns, in the case that it succeeds, it's going to return the contents of the file. And you can see that we've assigned to a new variable called data here the result of executing that awaited promisification function. So in addition to this ability for the await keyword to tell JavaScript to delay until a function has been executed or until the promise behind that function has settled, if we have a promise that's returning a value, in other words, one that eventually invokes the resolve function in the promisification function to hand a value back out, we can consume that value by just assigning a variable to the return value from the await that's waiting on this asynchronous function to complete. So when we get to this statement, we are going to invoke the asynchronous function. Then the await keyword is going to wait for that thing to resolve. And if we just assume for the time being that that resolves successfully, in other words, the resolve gets called instead of reject, the argument that's passed to resolve is going to be returned by the await itself so that we can capture it here in a local variable. And then we can also just continue to do completely synchronous code, right? After we get that value back, the await will cause execution to pause until the read file promise resolves. If it works successfully, then data will have the value that was read from the file, and we can just go ahead and log it like normal. And then the final asynchronous operation we're going to do is to do the unlink to get rid of that temporary file. And we're doing the same thing here. Do the await, that will kick off the asynchronous operation. When the promise settles, the await will have waited for that to take place. And then we'll finally finish out with the last console.log here completed. So behind the scenes again, I'm going to keep hammering on this, I guess. We're still using promises, which are wrappers around callbacks. But the await keyword allows us to simplify the way that the code is written in a way that makes it much more familiar. If we had made all of these fs, write, append, read, and unlink functions synchronous functions, right, we could have called them in very much the same way by just calling one after the other and then calling other code that doesn't involve any I/O, just like we would normally expect to. By introducing await here, we can essentially write code the same way, but under the hood it still is going to be running as an asynchronous function that's then going to do something that we ask it to do, and then when it resolves that promise, it'll go on to the next thing. Now, so far we've kind of been assuming that we've got a successful completion of all these asynchronous operations. And what we also want to be able to think about is how do we deal with errors? Well, the second kind of neat thing about using the async await syntax is that because we're kind of stopping and waiting for each of those asynchronous operations to complete and sort of interpreting the results that come back from the promise, there's sort of two things that can happen, right? A promise can either be fulfilled or rejected. So if the underlying code calls the reject function, it's going to be rejected. If the underlying code calls the resolve function, it's going to complete successfully. And we've already seen here kind of what happens in the case where we call the resolve, right? If the fs read file promise has succeeded and the underlying code has called the resolve function, that's going to signal to the await keyword, hey, this worked okay, and here's the value we got back from a successful completion. Go ahead and return it and hang on to it if we want. In the same way, if any of these asynchronous functions has a problem, in other words, if the underlying promisification function calls the reject method on the promise, then what's going to happen is the await keyword is going to also be made aware of that. And instead of doing something like returning the value, it's actually going to raise an exception. And that means that we can just use ordinary try catch syntax in JavaScript to do error handling. So if any of these asynchronous functions here in the main block of this function throws an exception, in other words, if any of them move from a pending state to a rejected state, the corresponding await keyword is going to take the error object that's returned by the promise, the one that you pass into the reject method, and it's going to raise an exception with that error object as the object of the exception. So if we put a try around this, right, all of these functions here are going to be subject to being caught if they raise an exception, and then we can have our single error handler catch with the error argument, and that error argument is going to be one of those error objects that we're normally passing into our reject function. And in that case, we're going to just run this the body of the catch clause to report the error and exit in this case. So the async await allows us to code using asynchronous functions that return promises almost as if they were synchronous, including both the kind of run one line at a time kind of behavior and the ability to do error handling like we do in normal synchronous JavaScript code. And then the final thing to note here is that the async keyword here has to be present when you declare a function that's going to use await anywhere. Right? So we're sort of flagging that this function is going to do await stuff, asynchronous things using await, and that allows us to do this code as we've been looking at inside the function itself. Finally, let's take a look at how we run this stuff, how we'd run this async function. So here's a new function called demo, and I'm going to print a little log message that says this one should work. Remember that in the previous uses of this example code, I've been calling the function on an actual file in my file system, and I've also been calling it on a directory so that it intentionally doesn't work, just to illustrate the notion that, that we can handle errors as well as the happy path. So we're going to call write, append, read, unlink. Right, that's the function we just defined back here with that super awkward name. And we're going to pass in the name of the file and the value that we're going to initialize the file to contain. So those become these two arguments, and we run the code that we've just been discussing. And when it's all said and done, we get a output from the write, append, read, unlink function that shows us the original value, double the value, and then that completed message. So notice that all of this stuff is happening in a nice order, right? We get out the data, we print it out, we get the completed message, we print it out. Everything looks like it's actually running in a synchronous kind of way. From the outside, it kind of works that way now. And then we can also try the case where we're going to get a failure because we're trying to write to a directory, which isn't something that we can do in this way. So we see the should fail output from this console.log, and then the output from write append read unlink is going to be the catch clause. We have a problem when we try to actually do this first write, and that throws, is going to have the promise resolve into the failed state, and then, or the rejected state. The await is going to interpret that rejection as an exception to be thrown that's then going to be caught synchronously by the catch clause, and we'll print out bummer and then the details of the error information that was passed up from below. So we see bummer, error is directory, illegal operation on a directory, and so forth. It's not able to open a file called dot because that refers to a directory. Notice again, though, we're calling, in order to get this to behave properly, we're invoking the asynchronous function that we wrote, right? Remember, this is an async function. So we're invoking it with await because we want to have this whole asynchronous thing complete before we go on to the next step in our top level function here. Again, because we have awaits going on in here, we also have to make this function be declared async. That's always going to be the case. And then the final thing that I'm showing here is just invoking that function itself by just calling it directly. Now notice that I'm not trying to do anything to wait for this demo function to complete. I don't have an await going on in here because it's the only thing I'm running, right? So although once you, again, as I mentioned before, there's kind of this rule of Yoda that once you start doing async, forever will it control your destiny. At the point where demo is called, I'm still just kind of running synchronous code, and I don't care how long it takes or what the sequencing is in terms of other functions that I might be calling here at the top level. I'm just invoking that demo function, and when it's done, it's done. And I'm really only doing it because I want to see the output going on here. So at the top level, at some point, you're going to have to call a function that doesn't have an await on it. Otherwise, you'll have to wrap that up in another function that has the async keyword as well. So I think you'll agree, perhaps, that this provides a pretty intuitive way of writing asynchronous code in a way that sort of looks synchronous, subject to these caveats and the new keywords. That said, it's totally legitimate to do things with callbacks or with promises or with async await. All are still in active use, although I would say kind of the callback style is falling more and more out of favor for publishing, new modules on npm.js and that kind of stuff. They're more often are returning promises, and any module that returns promises in its API can be used either with the promise directly with the .then and the .catch, or you can use the async await syntax to have the JavaScript runtime help you sort of interpret the behavior of the underlying asynchronous functions in a way that looks and behaves like synchronous code.